general relativity step by step. Last time I was looking at the way that components of a gradient change, which I call GI, and I made the observation that the components of a gradient transform with coordinate transformations in the same way that the basis vectors EI change. And it's a bit nonplussing when you see that. You think, well, yeah, of course they do. It's not very hard. What I'm going to do is to give you a different type of object with components that change in a different way. And then you'll see why this equation is, although you'll be able to put this equation in some kind of context. What I've got is a vector v, and what I want to do is to decompose it into a plus b plus c, where a and b and c are just real numbers. So it's just a decomposition of v into its into a basis. And of course the notation sucks, so I'm just going to rewrite that as E1 plus V2 E2 plus V3 E3, and V1 and V2 and V3 are just components, they're just numbers. Now what I want to do is I want to rewrite it in just the same way, but I'm going to decompose it into E1 bar times something plus E2 bar times something plus E3 bar times something. And the somethings I'm going to say are V1 bar, V2 bar, and V3 bar. My writing's going a bit messy there. Let's just get rid of that. Make that a 2. V1, V1 bar, V2 bar, and V3 bar are just real numbers. But they're going to be different, and I want to relate V1 to V1 bar and so on. I want to figure out what V1 bar is in terms of V1. Conceptually what I'm doing is this. I've got a vector here. Here's my vector V. And if somebody gives me a coordinate basis, which I'm going to write in red, E1 and E2, I can decompose that into V1 E1 plus V2 E2. If somebody comes along and says, well, that's great, but I want to express that same vector in terms of a tilted coordinate system, let's try tilting it this way, E1 in blue and E2 in blue, then of course my coordinates change, and I've got V1 E1 in blue and V2 E2 in blue. And of course I might even have a non-orthogonal system, which of course you will do in general. We might have some kind of crazy system like that in green, E1 green, E2 in green. And of course if I want to represent that, I've got to go down there and up here. Is that right? It's not quite right, is it? Let's see. That's what I want to do. So what I want to do is to have E2 going in that direction there. So I got the example first and I couldn't quite get the arrows the right way. V1 E1 in green and V2 E2 in green. So let's just study this picture here. We've got the same vector V expressed in different ways in red and blue and green coordinates. Which is what I've written down symbolically here. And what I want to do is to use the transformation laws of the basis vectors E1, E2, E3 in terms of E1 bar, E2 bar and E3 bar to relate these quantities V1, V2, V3 with V1 bar, V2 bar and V3 bar. But I'm going to do that in the next screencast. I'm going to stop there.